Hello again. Hi everyone. My name is Yaya. I'm a technical director at HTZ, and today I have a new topic and a new video, and this time it's on incoming earth station coordination. So the scenario is as follows. So there's an entity or an organization or company who's looking to license an earth station uplink operating on the 28 gigahertz, and obviously they need to follow ITU. So they produced an ITU SRS database for the technical parameters of the earth stations, and they submit it to the regulator or the regulators that are impacted by this earth station. So this video is a guide effectively teaching regulators how to proceed with the coordination and how to check if there's interference. So there usually coordinations on the 28 gigahertz earth stations. Usually you've got two concerns depending on what you have deployed in your country. For example, we know some microwaves operating on that millimetric wave. So that would be coordination between earth station and transmission part and the microwave links RX part. Another scenario which was also covered in separate video previously. Some countries they have IMT services on the 27, 28 gigahertz, and for example 5G millimetric waves, and here there's a concern of interference from the earth station to nearby IMT services. So this video is going to focus on the first topic only, and like I said, the second topic has been addressed in a separate video. So let's get started. So I'm going to do this coordination using HTZ communication and its built-in plugin ICS manager node database. Okay, so first we run HTZ. So this is the incoming access database that I received with all the technical parameters for the coordination. And here we have a map for the area of interest. I'm not going to show you how you produce the maps. Most of the HTZ users have a very good idea how to set up the map for the simulation. So I'm going to use this database, and this is ITU SRS version 9.0, I believe. So let's get started. So first I'm going to open project. So make a new project, and I'm going to drag and drop the maps that I have here, and then I'm going to save the project, override the existing one, and open the project. So this is the area of interest, and quickly familiarize ourselves with the map. So the map is 20 meter resolution map. And here we have a clutter. That's the clutter, and these are the default settings for the clutter. We'll come back to it later on. This is obviously not a high quality, but we'll do just fine for now. So now I want to import this this database, the SNS or the SRS database. So to import it, you need to run a plugin in HTZ which does the translation and the interface with ITU. So you'll find it under the tools, extensions, and ICS manager node database. Clients that have license of ICS manager do not need to run the node database. They can just run the standard one. So I'm going to run HTZ ICS manager, and I'm going to make new workspace. Because I don't have a project handy, so I need to make new one, new workspace, and I'm going to call it maybe Earth Station coordinate or ITU, for example. Create. Now we have a workspace. Next you need to connect that workspace to the SNS, which is the incoming coordination, and then you can feed it directly. This is SNS coordination. So connection is done, established. Now it's easy. All you have to do is to do save. This is save. Make a new query. You can do it from the file, new. You can just do it from here. Queries, right click, new query, and you go to ITU, and you see this is the SRS. This is Briefik, FM TV, LFMF, Geneva, and so on. I want SRS and notification. Here we go. You can also connect to the Earth station if you want to see the technical parameter of the Earth stations, but I prefer you do it from the notice. Double click on the notice, and the notice is done. So save this workspace. So here we go. This is the incoming coordination. And you can see this is a standard ITU SRS database, but usually you have other agencies or other entities who are doing coordination. But obviously here this is a sort of a reduced version of the ITU database. It only has the notification or the coordination for that entity. So normally you just right click and then you import to HTZ on the map. That's pretty much it. Okay, but before I do that, I want to actually open this notification and have a look at the contents. So you can see here we have station information, like you can see the date, you can see the version here, you can see you can expand the station, and you can see the name of the station. You can see the longitude, latitude information. Okay, so I want to look at the technical parameters quickly just to familiarize myself. So I go down to antennas, expand the antenna. So there's 1, 2, 3, 4 elements. Maybe RX, TX, TX, or the other way around. Okay, so I can expand number 1. So E is emission. This is emission type number 1. Number 3 is reception type. So I'm interested in transmission because, like I said, I'm going to examine interference from the Earth station to the microwave links. So I'm going to go here, expand number 1, and expand the groups, expand the first group, and now you can see here the bandwidth, the frequency min and max, and you should be able to see the actual frequencies included. Now here it's a bit confusing because the minimum frequency is 2.7, maximum frequency is 2.9, but when you expand the frequencies assigned, you can see it's actually the frequency is 2.7, so 27.5 gigahertz. So they're using the minimum frequency as transmission frequency instead of using center frequency. So this is the number 2, which is 2.9. Here we go. So these are the two frequencies that I want to import together with all the technical parameters, antenna model, and location, lat long, and so on. So this is how you examine the information. Now you want to import directly, just go right click like this and then convert, send Earth station to HTZ on the map. Now the first time you do this on your computer, ICS manager and HTZ need to be have exchange folder. So you go like this and then you use local exchange folder, and we go normally to C, ATDI, HTZ communications, and you go to the base folder. That's the base folder. That's where you can find the rest of the technical folders required to exchange, for example, something like antenna pattern or emission mask, transmission filter, and so on. So hit OK. So here is just the software can deal is asking you how would you deal with missing parameters, for example KTPF and so on. Okay, so you can define default values and stuff like that. So I'm just going to hit OK for now. Here we go. Imported for stations, done. So this is my Earth station now. If you don't like this viewing, go F5, standard 16 by 16. Here you go. That's my Earth station. So actually there is 4, 1, 2, 3, 4, and obviously these two are RX and the last two are TX. So I can actually go to the list and maybe just delete. I can delete this one here. This is the receiving channel, and I'm not really worried about reception, because reception is different band and the incoming coordination is for transmission. So 2.9, 2.7. Again, I'm not 100% confident that the notifier entity have really given here in an ITU database format the correct central frequencies. Instead, they just gave the extreme or the edge frequencies. Now you need to double check what you're doing. Okay, so I know this entity has 80 watt, but normally guys, the power the power will be also imported. The power transmission power will be also imported directly. So you can see 2.5 gigahertz bandwidth, and you can see that about 28 gigahertz frequency, and antenna gain 58. I had to take control of the power, guys. So I set up the power here manually, but in the next version that should be automated. And here we have the antenna pattern. So the antenna pattern, you might need to pay attention to the incoming coordination. So usually not all the informations are embedded correctly in the ITU database. So you might need to collect the information through the notifying body. So here in this example, I know that this one they start transmitting because they're tracking NGSO satellite L5. So they start from 5 degrees and they don't transmit under 5 degrees. So I can emulate that by going with a smart antenna, and then I can start, for example, pointing up 10 degrees, and then let's say swinging up and down by 5 degrees here. And because it's rotational antenna, so you can rotate horizontally by 180 degrees. Okay, so what does it mean? It means the horizontal antenna movement is a 360 plus or minus 180, but the vertical movement is only from 5 degrees to 15 degrees, and you don't need to go higher, 20, 30. It doesn't make any impact in terms of emissions. So I'm going to really allow the software to move the vertical beam from 10 minus 5 to 10 plus 5. Okay, so 5 to 15. So this is really a very effective way, and you can see the antenna pattern is already captured from the database. And you can see there's two frequencies of operation here, 2.95 and 3 gigahertz. And like I said, I'm not really confident that the notifier did the right thing here in terms of putting the actual center frequencies. So you might need to be mindful of that. So I don't care about reception information of this earth station, because all I care about really is the ERP is correct. Antenna height here, I'm going to make assumption that it's 15 meter height. The information didn't come through as well. Maybe they're not included in the notification. And antenna pattern is there. So this is what you need to pay attention to: general frequency, pattern, and channels. So make sure everything is sound and correct. Jump to the second station now. Here you go. Second station has slightly different parameters. So it's again, maybe it's 80 watt and 2.7 here. I'm gonna go 15 meter high here, and the pattern is the same story. I'll go with plus or minus 180 here, and then plus or minus 5 degrees, and I'm gonna point it up by 10 degrees, so I can go down by 5. So that's pretty much it, and you can see here the frequencies are there, frequency of operation. So that looks good. Now I've got my two earth stations imported and ready for simulation. Now here you need to have microwave links. So normally, like if I am in Australia, for example, I can connect directly to a ACMI database, and I can import the microwave links on the map. You can import microwave links from your database in many ways. If you already have a TDI product like ICS Manager, then you are covered. It's fully automated. You can just quickly import it. But if you want to import microwave links from CSV because you have a third-party tool, then you can go import generic microwave links. All right. So for now, I'm going to just make this manually, and I'm going to choose a frequency 2910. Okay. So co-channel. So I'm going to make a microwave link quickly. Microwave link. So that microwave link, let's say, is from here to here. All right. So let me do the full configuration here. Let's call it incumbent microwave. And I'm going to choose one of the equipments that I have here in my database. It need to be really on that band ideally. I'm just going to use anything for now. I'm just going to create a dummy microwave link, but I'm going to put the frequency to be around the center of frequency that I have here. I think it was 29100 if I'm not mistaken. So 29 gig roughly, and let's say this is doing on 29 as well. So this is TDD kind of link, and here let's say this is 30 meter height. So I've got 19 dBm, everything is in place, and here I'm going to use 28 megahertz bandwidth. KTBF is very important. You need to set the KTBF. I'm assume noise figure 4 dB, and this is the roughly 28 gigahertz band. So we're looking at negative 96 dBm. So KTBF is extremely important, guys. It needs to be defined correctly if you want to do frequency interference analysis in TDD mode. So antenna pattern. So I'm going to choose one of the vendors here, or I can just simply use ITU. I prefer to use ITU for now for quickly. Here you go. So now I can use ITU 699 to calculate the antenna pattern from the frequency and from the antenna gain. All right, so that's how it works. So that's it, done. So I've got my pattern in place, and I've got my general tab configured, and the most important thing is KTBF. So my link is up and running. So this is my link, this is my earth station. So the question is, you can have hundreds of links here. All right, the question is, does this earth station cause interference to these incumbent microwave links? All right, this is the question we're trying to answer. So you need to make sure you've got a good propagation model in place. So you must use something like ITU 452-17. Okay, I'm going to use the default settings from 452. Close, and ducting is enabled. You see Bullington is enabled, and ITU is enabled here. And time percent, I'm going to go with 5% for the coordination purposes. So close. Now we go to microwave, and then we go to interference microwave, and I'm interested really in this option here, threshold degradation technique. So if TD was too pessimistic, you can use C2I technique. So usually we need around 64-65 dB protection ratio for microwave links. TD, we usually target 0.5 dB. So I'm going to go here, impact off stations such as earth station on microwave links. Click on the RF, always use n equal to 0 to be 0 always, and then here is IRF from ITU and ITSI. So all is good. Now we run a simulation, and here we go, we have interference in that case. So pink here means that the links are interfered, and you can see that the TD level is very high. All right, so this is, guys, imaginary situation. Okay, I just dropped them here, and I'll make another link anyway, show you the difference. So you can see here 57 dB degradation for this head, but this head here is only degraded by 9.7 dB. So now I'm going to make another microwave link just to show you the difference, but this time the link is going to be running like this. Microwave link from here to here. Alright, so this is microwave link number two, and then I'm going to use exactly the same parameters as before, orient antennas, and bingo. So now this is the second link. So again, go to microwave interference, and same technique, same RF, hit OK, and now we can see that this link, these two links, they have also a level of degradation, but it's only 8 dB for both of them. So let me make one more. This one here, orient. So now we've got 3 links and 1 earth station. So you go to microwave interference, impact of station on microwave links, hit OK. So the last ones are also interfered, but it's only 5 dB. Now let's see what happens if I use actual antenna pattern. So microwave list, and let's say use the last one. So the last one, let's now use actual antenna pattern. I'm going to make use of RFS. Hopefully I have something suitable for this. Let me use this one for now. Orient. Let's see if that improves. Microwave interference. You see now we've got some improvement in one of the links. So the TD is only 0.4, just under 0.5 dB. Okay, so that was really just a quick analysis of the impact of this earth station into these microwave links. So the tool is going to spread the power over the bandwidth when calculating the interference analysis, and it's going to automatically steer the antenna pattern for the potential orientations that we defined here. So that's it, guys. So this is how you can really import ITU SNS database for the earth station incoming coordination, and import on the map, set up a software, and run interference analysis into your existing microwave network. Thank you, guys, and stay tuned for future videos.